Gabe Jenkins back with you here with the CCA, College and Career Accelerator, accelerating your future. We are in the very beginning of our class on manufacturing processes. So we are still in the stage of the class where we are absolutely just trying to get our hands around really big picture stuff around manufacturing, how it's organized, ways of thinking about it, that kind of thing. Yesterday, or in the previous video, we talked about like how to define manufacturing, what's important about it technologically, economically, financially, um, in terms of historically, a lot of different ways about thinking about manufacturing, how large of a role it plays in our economy, and then just kind of like a few other things we talked about what manufacturing is. Then we ended up yesterday's presentation just a really high level overview of what kind of materials are used in manufacturing. We talked really briefly about the fact that there are metals, ceramics, and polymers that are used in manufacturing. We're going to leave that to the side for now. And we are going to move on today. We're going to talk about really high level and what are manufacturing processes. And that's going to be the focus, just to be clear. This point number 3 that we're going to introduce today is going to form really like the large bulk of what we're going to learn over the course of this semester. What are the different processes that manufacturers use to make and assemble the different parts that are used in goods that people buy? We're going to follow up this by just talking about different ways that manufacturers organize their factories based on largely like their production capacity, how many things they're trying to make, and the variety of the things they're trying to make. So bringing back the idea of P and Q variable from yesterday, those variables are not just some random variables that appear on a chart, but they are really important things to think about when manufacturers set up their factories and try to figure out like how they're going to make the things that they want to make. Okay, so that's what today is. All right, so manufacturing processes. On a very high level, manufacturing processes can be broken into 2 main categories. There are things called processing operations, and there are things that are called assembly operations. Processing operations, move that over here, down here maybe. Processing operations, they take a starting material and they transform it in some way to make it into a more advanced state, like higher value, more close to what they need in the final product, right? So processing operations are things that change the geometry, meaning that's the shape of the object, the properties of the object, meaning like the physical properties of the object, how hard it is, how flexible it is, things like that, how durable it is. Those are the properties, and then or the appearance, and that could just be surface finishing, it could be painting, it could be any of a number of things that change the appearance. So processing operations include all of those things that change the shape, the properties, or the appearance of a material, right? These are all processing operations are all things that involve how do you make a part, right? How do you make the parts that are involved in a finished good? Assembly operations are just all the different processes that manufacturers use to join parts, either permanently or just temporarily. Okay, those are assembly operations. 2 main types of manufacturing processes. We are going to spend a decent amount of time over the course of this semester understanding all of this chart, right? So we talked about manufacturing processes being proper processing operations and assembly operations. And today I'm just going to very briefly introduce all of these things and not get into any depth in them really at all. But then we're going to spend a lot of the bulk of the semester talking about like what is a solidification process? What is deformation process? Like what are these things, right? And so just in a nutshell, just know that we're going to come back to this chart again and again and again. And it's important that you have a good understanding of how this chart is organized and why the different things that are organized together share things in common. Okay? So processing operations can be broken into shaping processes, property enhancing processes, or surface processing operations. And assembly can be, it's either permanent or mechanical, meaning temporary as well. Okay, so processing operations. We talked really briefly. We said that processing operations alter a material's shape, physical properties, or its appearance to add value, right? So shaping operations, if I go back one chart, shaping operations are up here in the red. Shaping operations are the things that change the shape, change the geometry of the starting work material, right? Make it from a block into a curved shape, or take some material away, or change like like the angles of something, right? So those are shaping operations. Property enhancing operations do not change the shape intentionally. Sometimes they just change a tiny little bit, but it's kind of like a side, it's like a byproduct of the actual process that they're trying to do. But they improve the physical properties of the material that you're working with. Things like they make the material more durable. They make it harder. They make it easier to bend, harder to bend, whatever they're trying to do. They usually do that by heating it up and cooling it down in a very, very controlled way. Okay? Lastly, we have surface processing operations, which again, don't change the shape. They don't really change the properties of the material. They just change the surface. So they clean the surface. They treat it with certain chemicals or materials that make it impervious to rusting, or they coat it, or they paint it, or they sandblast it to make it smooth. All of these things that just work on the exterior of an object are surface processing operations. They don't change the shape. They don't change the actual underlying physical properties of the material. It's just all exterior stuff. Okay? In shaping processes, so these are the things that change the shape of an object. There are four main categories of processes that factories use to shape a material. The first one is called solidification processes. This is the only one where you take a material, often a metal, but sometimes plastic as well, and you heat it up until that material is liquefied, right? You heat it up until it melts. Then you change the shape, maybe by pouring it into a mold or some other process, and then it cools down and solidifies. That's why it's called solidification processes. So solidification processes take material, melt it to a liquid, pour it into something, and as it cools, it takes a new shape. That's why it's changing the shape of the material, right? Particulate processing, also called powdered metallurgy, is a super interesting process. You take powdered material, usually metal, usually a mix of a bunch of different kinds of metals, and you take that and you press it into you take that powdered material, press it into a specific shape, and then you barely heat it up a little bit just so it becomes sticky, and all those little powders stick together into a final product. So you're going from a powder to a shaped product, so that's how you're changing the shape of it. Deformation processes don't heat up the material, usually. I mean, like not to the point of melting. They can heat it up, but not to the point where it becomes a liquid. And it just using raw power, usually, you pound a piece of metal often into the specific shape you want. So if you imagine like a blacksmith making a sword or something, right? They heat the metal up and then they just pound it until it gets to the shape of a sword. So that is a deformation because you're deforming the original material into the form that you want. In this case, it always has to be, maybe not always, almost always has to be a metal that is ductile. So a ductile metal, some people in different countries pronounce it a different way, ductile. Ductility is the property of a material that allows you to press or bang on one part and it changes shape without shattering. So like glass is not ductile, right? If you bang on a piece of glass, it'll break. But if you bang on a piece of metal, it'll dent. So ductile means dentable, basically. Lastly, and all of these processes kind of like they don't change the amount of material much that you use. Like you heat up a certain amount of metal, pour it into a mold. It's the same amount of metal. Particular process, you start with a certain amount of powder, you put it into the mold, you press it down so it sticks together. You're not really wasting a lot. Deformation processes, again, you're starting with a certain amount of metal and you're banging it. You're not like eliminating material, you're just putting it into a different shape. This last category of processes though, material removal processes, they're processes where you are starting with a block of material and you're basically just shaving away the parts that you don't want. Okay? That's why it's called material removal. You're removing material away from the original block of it. So these categories of processes, this category of processes wastes a lot of material, right? It does. And you're going to see when we start moving onto the CNC machines in our lab, you start off with a block of material and you're losing a lot of the material because you're shaving it away. We'll talk about why it's still a good method even if you're wasting a lot. We'll talk about that when we get to it. But it's the one process that loses a lot of material. All right, so solidification process is just really quickly. What happens is you take a metal or a plastic, usually a metal, you heat it up to the point that it's a liquid, you put the liquid into a little bucket, and you pour that liquid into a mold. Sometimes it's an open mold, sometimes it's a closed mold, and that liquid falls into a cavity, and that cavity is an open space. And over time, sometimes in 5 seconds, sometimes it takes a little longer, maybe sometimes it takes an hour, it cools off, right? And as it cools off, it cools and it takes the shape of the interior cavity of the mold, right? And so you start off with whatever shape you want to, melt it into a liquid, pour it in here, and as it cools off, it takes that shape. This with a closed cast like this, where you're pouring it into something with a closed top, there's very often a part that you need to kind of cut off and remove at the end. It's the part where it's not really, like this is just this rectangular shape here would be the part that you're trying to create. This part here is just kind of like the tube that lets the material in. So you very often have to cut away from like here over, from here to the left, because that's not the part you want. And you would keep this part here. So it's pretty efficient. It doesn't waste a ton of material. But the basic process is just heating up to a liquid, pouring it into a mold, letting it cool off, and then cleaning up that finished product, okay? But that's creating the shape that you want. That's why it's a shaping process. The second set of processes, called particular processing, also called powdered metallurgy. You start with a bunch of powder, and it can be copper, it can be steel, it can be iron with nickel, it can be whatever blend of powders you want, and they're very often very specific about the exact blends and the proportions of each type of metal that they want in the powder because they're making a finished part. So you take this powder, you pour it into a mold, and then you pound the powder together. You're like squishing it together. So all these little powdered pieces kind of stick together, right? They're pressed into the shape that you want from the final product. But it's still pretty fragile because it's just like taking a bunch of powder and sticking it together, pounding it together. They're not like actually stuck together in any way yet, really, other than through force. After it comes out of this punch, out of the mold, you then heat it up slightly just to kind of like barely melt the edges of all the powdered particles so that they stick together. That process is called sintering. But this whole process of creating powder, of starting with powder, pressing it, and then heating it together so it sticks all together to create a newly shaped product is called particulate processing. Particulate just means powder, particles, okay? Deformation processes, again, often sometimes they do heat, sometimes they don't, but they don't heat the material up to the point of melting. They just heat it up because it becomes a little bit more easy to work with. If you imagine like a piece of chewing gum, right? If you heat it up inside your mouth, it becomes a little like gooier. It's easier to push into the shape that you want, right? So deformation processes start with a block of material, and they use tremendous amounts of forces to just press these shapes into the shape they want. With forging, you pound it into a specific die, like this. You'd have a block, and as this part comes down and this part stays still steady, the material in the middle gets pressed into a specific shape that you want. That's forging. There's open forging, there's closed forging. There's a lot of different kinds of forging, which we'll get into, but that's the basic idea, is you're just pounding into the shape you want. This over here is called extrusion. And so we've heard that word before when in our SolidWorks careers, extruding. Basically what extruding is you have a certain amount of material, you have a certain, you have like a press that pushes on the material, and over on this side of your extruded material, your extruding machine, there's a specific hole. And as you press a larger block of material and give it the only out that it has is through that hole, it takes the shape of whatever hole that is. If you've ever played with, my favorite example of extrusion is if you've ever played with Play-Doh and had like a little machine, like a little toy where you press the Play-Doh into something and it comes out a little hole, maybe it's a star shape, maybe it's the barber shop, which is the best one they ever had. The barber shop one is, it comes out as hair on somebody's head. But as you press a material out of a little hole, it takes the shape of that hole, and so that's what extrusion is. Okay, cool. Last shaping processes. There are material removal processes, and this is gonna be a large portion of what we learn at the end of the semester. We're gonna learn about turning, aka lathing, and we're gonna learn about milling, right? And so basically, these are processes that start off with a large amount of material. Something spins around and cuts like the material away, and you're left with whatever shape of product you wanted, right? So if you start off with like a blank cylinder and you cut away certain parts of it, you can end up with a baseball bat. If you start off with just a square block of material and you cut out a hole out of the center, then you have a block with a hole. So you're changing the geometry by cutting material away. Okay, so the main things that we're going to learn about in this class are going to be turning and milling, but there's also just drilling holes that cuts material away, and grinding. If you've ever seen like a grinder, like sharpening tools and stuff. So those are material removal processes. They waste a lot of material. They are not very efficient in terms of material, but they do get very, very, very precise results if you know what you're doing. All right, so let's talk about waste real quick. Obviously, it's desirable if you're a manufacturer. It's very desirable to not waste material, right? Because you're buying, say your part only requires 1 pound of aluminum, and you have to buy 3 pounds of aluminum just to make that one thing. That's really inefficient, right? That's wasteful. You have to spend all that money to buy all those raw materials, and a lot of it just ends up on the floor. So that's inefficient both from an environmental perspective, right? But it's also really inefficient financially and economically. You're wasting a lot of material and therefore eating into the amount of money that you make as a company, right? So companies really, really try hard to develop ways of making things that minimize the amount of waste that they create when they're creating their products. So casting and molding and particular processing are pretty efficient. Casting means you're just pouring things into, it's like solidification. You're pouring liquid stuff into a cast. You end up with a piece that looks pretty close to the thing you want. There's very little waste, right? Molding, particular processing we talked about, where you're pressing the powder in, it doesn't waste very much at all, right? So those are pretty efficient things. Material removal processes, really, really inefficient, really wasteful. As a manufacturer, they think about like how to describe the efficiency of your manufacturing processes. Net shape processes. Net shape. Net means like if you zero out everything that you brought in and measure everything you end up with. Net shape processes are processes where there's very, very little to zero lost material, right? There's very little extra work that has to happen to clean it up or to cut off parts at the end of the shaping process. So net shape processes are very efficient. Near net shape processes are pretty efficient, but you have to cut off like if you think about like this part right here, you'd have to cut off all of this, right? And that's kind of inefficient because then you'd have to melt it down and maybe reuse it. Maybe you can't reuse it in some cases. So that's like a near net shape process because you're losing some of your material. But I would say this, net shape processes like particular processing almost eliminate entirely waste. Near net shape processes like casting waste a small amount of material, but they still waste some. Something like material removal processes, though, are neither net shape or near net shape because they just waste a ton of material. They just cut it away and it's left in the machine or on the floor, and you got to just like throw it away. Okay, so that's where we are with that. So that's the end of shaping processes. All the things we just talked about are ways that you can change the shape of a raw material to make it into a more advanced state and make it add value added to the original starting material. Okay. Second category of processing operations are property enhancing processes. These are processes that you do that improve the performance of the material you're working with, right? Either make it stronger or harder or more flexible or less flexible, whatever you need from the product. These are property enhancing processes. Properties meaning like chemical and physical properties. Enhancing means to make better, right? So these are things that you do just to enhance the internal properties without changing the external shape of the product at all. Sometimes the shape changes, a tiny bit because it's just a byproduct of heating. But the intention of the process is not to change the shape at all. The intention of the process is to make the properties more like what you're looking for from the end product. Okay, and simple examples include heating and cooling of certain like steel products to get the exact alignment of internal molecules that you want to make them the exact right hardness that you want. Or sintering. Sintering, again, is just a light heating. It's like a warming up of the particles in powdered metallurgy or particulate processing. Sintering is just like heating things up just enough so that they stick together. Okay? So those are property enhancing processes. The last group of processing processes is surface processing operation. Again, these are things that don't change the shape of an object at all. They don't change the internal properties of the material at all. They just deal with the external surface of the material. So things like cleaning the surfaces to remove oil and dirt and other things. Surface treatments, so things like sometimes it's mechanical, like where you're blasting it with sand to clean it up and to remove rust or other like external surfaces. And sometimes you're dipping it in like an acid to clean it up a little bit, right? So that's another way that you can clean up the surface. And lastly, there are surface coating, where it's a very, very thin layer of material that allows you to protect the surface. So things that, cover it so that it doesn't rust. Well, it's usually a chemical bond between whatever you're putting the part into and usually a bath that you dip something into, or you spray the surface coating on something. It's basically either painting it or making it so that it is resistant to external damage. Okay? But those are surface processing operations, only affect the outside, the exterior of an object. All right, so all the things we talked about in that first section are just ways that you can change parts. You can make a part that you want to be part of your final product that you're trying to put together or sell. There are several other, once you think about a car, it's got thousands and thousands of pieces inside that car, right? And some processes are needed to put those together. So you start off with all the parts. They've all been put into the right shape and given the right properties and covered and cleaned and all that stuff. And then you have to assemble them together. So assembly operations don't change the parts, just put them together, okay? As the word implies. Two or more separate parts are put together to join a new kind of like more complex thing. And that's how you're adding value to the materials. There are two categories, one of which called joining processes create permanent bonds and permanently join two objects. Mechanical assemblies are temporary. They are reversible. You can unattach things that are just attached mechanically. So joining processes up here are things like welding, brazing, soldering, or using glues and adhesively bonding two different parts together. They're permanent. Like if you've ever seen welding work, they melt metal along the joint between two pieces of metal. They melt them together so that they are stuck together permanently. Similarly, brazing and soldering work in a similar idea. Adhesive bonding, we'll talk about more, but that's just like gluing things together. Mechanical assembly, on the other hand, is things like screws, right? Nuts and bolts. It's things that you can stick things together, but you can just you can unscrew the bolt and unscrew the nut, and unscrew the screw, and the pieces are separate again. So it is temporary, and it is reversible, right? So those are the two main categories of assembly. We'll get into a lot more detail later in the semester about joining processes more specifically, and we'll talk a little bit about threaded fasteners, screws, and how to understand like the specifications around different screw naming conventions. Okay. All right. So that's how you make the parts. That's how you put them together. We're going to talk in much more detail about all that stuff later in the semester. But for now, if you're a manufacturer and you got all those choices about, do you want to cast your parts? Do you want to forge your parts? Do you want to CNC your parts? How do you want to make your parts, right? Do you want to injection mold your parts? You got all your parts. How do you want to put them together? You got all these possible ways that you can create a final product, right? And it's up to you to try to figure out what's the most efficient way of doing that. And a lot of it really does have to do with the P and Q again. How many things do you want to make? And That's the Q. And how varied are the products that you're trying to make, which is the P, right? And you think about all those things, and you come up with a whole idea for what are your production systems going to be. How is your factory going to work? And that is a total, like, that's its own area of study. That is an incredibly cool, complex area of study. Just thinking about the most efficient way to make things, right? Anyway, so production systems include the people, the equipment, and the procedures that are used to make a final product, used to manufacture something as a final product so that you have something to sell, right? And a manufacturing firm must have all of the things in place if they want to be an efficient producer of goods. So the two main categories of production systems would be production facilities, right? Meaning people and buildings and machines, and the manufacturing support systems, which we'll talk about at the very end today. They are not the machines and stuff like that, but they're super important in terms of making sure that you have an efficient production process. Okay? Both production facilities and manufacturing support systems include things like a building or machines, and they both include people, but we'll talk about the differences as we go here. Okay? So production facilities, we introduced this idea the other day that there's different categories of, like, how many things do you make? Different categories of quantity of goods produced. Low production, meaning less than 100. Those places are called job shops, right? They're just super, usually very expertise workers and complex machines that allow those super expert workers to produce a unique product, something that's never been made before, okay? Medium production includes factories that make anywhere between 100 and like 10,000 final goods at the end of the year. We're going to talk about different ways that you can organize a medium production facility. And then lastly, there's high production facilities that are making more than 10,000 goods in a year that they're selling. And there's a couple of different ways of organizing high production facilities as well, which we'll talk about today. In addition to the facilities, there's also manufacturing support systems. These are things like you need engineers to engineer what you're going to make. Part of this program is understanding how to engineer products that can be manufactured, that can be made, right? And understanding how to design things that can be made. Production planning and control, those are the people who understand exactly how to set up the factory, set up the supply chain, set up all the logistics, all that kind of stuff. And then lastly, for today, we have quality control. Quality control is super interesting and super important. Say you make a screw. You're making a screw. And you tell your customer that your screw has to be able to hold a 500-pound weight without breaking. Well, if you're telling your customer that, and they're depending on that screw to be able to hold 500 pounds, you need to be able to prove that screw can hold 500 pounds without breaking. And so your quality control people exist within the manufacturing facility, within the factory, and their job is just to test everything and make sure that it does what you say it should do. And you need to be able to prove it, because customers are going to be really upset with you if you say it can hold 500 pounds and it breaks the minute they put something that's 400 pounds on it. Right? They'll come back and they'll sue you. So quality control ends up being super important, because if you say your product can do something, it better be able to do it. Okay? All right. So production facilities. We're going to talk about how factories basically are organized, and so things can be done the most efficient way possible, right? And so it includes like what machines you have in there, how it's physically laid out, how all those machines are physically laid out, so that you don't have to like take one part from one end of the factory all the way to the other factory and then back and forth. Like, you're trying to design things that are efficient, where people and the good can be made as efficiently as possible. All right, and so you're trying to organize all of the people and the systems and the machines, all of that stuff in an efficient, logical way, so that the process is efficient, right? All right, so we talked about low, medium, and high production. I'm not going to go into each one of those things, but just understand that there are different layouts and different understandings of the manufacturing process, like the layout and the organization of people, machines, et cetera, that are more appropriate for a medium facility versus a high production facility, And even within a medium production facility, if you have a lot of variety versus a small amount of variety, we talked about that the other day, the p-value, whether it's hard variety or soft variety, right? So let's talk about that, right? Low production, really small number of things that you're making, called a job shop. And usually the people who work in a job shop are really highly skilled people who have been making things for a long time, understand exactly how materials behave under certain conditions, understand how to bend materials, how to cut certain things. They know what they're doing. They understand really complex things. And so typically at a job shop, you have a variety of very flexible machines that can do whatever the skilled machinist wants the machine to be able to do. And you have very flexible machines that can do anything, right? Like a six axis CNC machines that, if you are capable of programming it, can cut out any shape out of any piece of metal that you want, right? And so what you're talking about here is getting a group of people together who are experts, who understand how to make whatever, and they're really using that expertise to make complex things in a very small number of them. Think like you're making one specific, so like the James Webb Telescope has, I can't remember the exact number of hexagonal reflectors on them, right? And each one of them is an incredible piece of engineering and manufacturing. But you have to have people who understand how to make those things. And so let's say there's, I don't know, there's like 35 of them. I can't remember the exact number, but it's like 35 of these extraordinarily precise pieces of metal. And you need somebody who's capable of making each one of those things, right? So something like that would go to a job shop. All right. That's small production facilities. Medium production facilities, you're making anywhere between 100 and 10,000 final finished goods at the end of the year. And how you set up your factory depends on if you are dealing with massively different products over the course of a year or just kind of slightly different products over the course of the year, right? We talked about hard variety versus soft variety. So hard product variety, say you're making computers for the first half of the year, and you are making plastic frisbees for the second half of the year. It's the strangest company that's ever been made, right? But you can just imagine, if you're trying to make computers for the first half of the year, and then you got to switch and make frisbees for the second half of the year, the materials you're working with are different. The manufacturing, like the processes that you're using to make the parts of the frisbee are different versus the computer. The assembly techniques are different. Everything is different, right? And in that case, if you're making computers for the first half of the year and frisbees for the second half of the year, extremely different products, hard product variety. The P is hard product variety, and you're going to have to shut down your factory in the middle of the year to reconfigure everything, hire new people, fire people, get new machines in there, get new sourcing for your materials because you're sourcing plastic instead of computers. Like everything's different, right? So if that's the case, you would set up your factory. Again, it'd be a stupid company, but if that were your company, you would set up your factory using something called batch production, where you're setting up your factory one way to make one product. You stop at the end of the production of that product. You reset everything, and then you retool your factory so that everything is set up for the second batch in the second part of the year. Hard product variety is that. Soft product variety, on the other hand, is where you have just like similar goods, but it's a little bit different, right? And so say you're making some of your computers have, I don't know, some of your computers have more RAM than others, some have more different hard drives than others, some of them come with a better monitor, like whatever, right? It allows you to kind of like keep your basic production facilities and processes in place and just kind of make small adjustments as you go, right? And so you have like a layout that allows you to make small adjustments to each product you make without having to reset everything. That is cellular manufacturing. All right, so that's medium production. High production facilities. When you're making more than 10,000 things in a year, high demand for your product, you're making a ton of them, right? And it depends on if you're making 50,000 cars coming out of your factory or 5 million pencils coming out of your factory. 50,000 cars, you can kind of make with an assembly line, right? Where you can kind of just add different things as you go, and keep the product moving along a pretty complex chain of sequenced steps to make your final goods. But it allows for more flexibility, right? You can imagine that a car, when you're making a car, again, you can swap out the radio, the better radio for the worse radio, the leather seats for the, for the cloth seats, etc. But you can kind of organize your factory and your production methods using a flow line, an assembly line, right? Quantity production is different. It's just like I'm making 1 million of this thing, and so quantity production is just like I'm making 5 million frisbees, and I don't change the machines at all. I don't change the raw goods at all. I'm just trying to crank out as many of the same things again and again and again as possible. In this case, you don't need a super skilled labor force. What you need are machines that are fully dedicated, efficient machines that are able of cranking out the goods as quickly and as efficiently as possible. So in a quantity production facility, think pencils, think frisbees, think anything basically simple that's the same thing again and again and again. And you're just going to make a gazillion of them, right? Flow line production is going to be something where the product is complex, something like a car, right? And you have to start with the frame of the car and then add the axles and then add the wheels and then add the tires and then add the brakes and then you add the seats and then you add the windshield, like all the separate things. Then all the electrical work gets hooked up. All these different steps have to happen, and you end up with an assembly line where you end up with the thing that you're making, the final good that you're making, flows through your factory, and different things are added to it, changed about it as it flows through the factory. It really is what you might think of as an assembly line, right? And specific parts of the factory are dedicated to things like electronics or seats, or making sure that all the mechanical parts are hooked on properly, or making sure that the exterior parts are hooked on correctly. Like it's organized into sections, but each one of those sections is really efficiently organized, and the logical process of making the final good makes a lot of sense, right? So that's flow line production. In addition to all of the factory, the people and the machinery itself, right? That was all of this stuff, just going back real quick. Well, maybe not as quick as I would like. All of these things are production facilities where you're producing the things using the factories and the people who work in them. But in addition to the actual the machines and the people who work to put the thing together, you need an additional support systems to make sure that the factory works as efficiently as possible. You need people to design the processes and the stuff and the parts and the equipment. You need people to plan and control production, like design how the factory is set up. And you also need to have people who check to make sure that your products are as good as you say they are going to be. Those are quality control people. So you need manufacturing engineering to engineer the parts and engineer the systems. You need people to control how the factory kind of like works on a day-to-day basis. You need warehousing. You need people to control intake of goods, and you need people to control the shipping out of goods. All of those things need to be really efficient, or the factory kind of grinds down to a halt. And lastly, you need quality control. So that's in a nutshell. Here is kind of what we're going to go over in the course of the whole thing. Much of what we're going to learn about in this class is focused right here on the manufacturing processes and assembly operations. But I did want you to have an understanding of how it's much more complex than just I got to mill something or I have to turn something to make a right shape part. Manufacturing is an incredibly interesting, really high need sector that's got a place for almost anybody who wants to get into it. And so I wanted you to have a kind of bigger overview of some of the decisions that factory managers and company owners have to make when they're setting up their company. All right, everybody. Magic phrase for today is have a great day. I hope you do. Have a wonderful day, everybody. All right.